Maritime transport utilizes lowest grade of fuel to run its propelling plant. This is one of the reasons which make it the cheapest mode for transporting goods to different countries. A mid-sized container ship consumes approximately 200 to 400 metric ton of fuel on a daily basis, depending upon the operation, speed, and engine efficiency. Before using the low-grade oil, such as heavy fuel oil for combustion in the engine, it is treated on ship at various levels. First, the FO is internally transferred from bunker to settling tanks. In the settling tank, it is stored and heated up to 50 to 60 degrees to separate it from water, which is drained off from the bottom. The oil in the settling tank is drawn out by the feed pump, which delivers the fuel to a thermostatically controlled heater to raise the fuel temperature to about 80 to 90 degrees Celsius before supplying it to the centrifugal separator. Then the oil is further treated in purifier, in which the water and solid particles are separated from the oil. The purified oil is transferred into the service tank, from where the oil is directly fed to the marine engines and ship's boiler. The centrifuge separator is an essential machinery in the engine room used for purification of fuel oil and for efficient combustion. Fuel, which is rotated at high speed using external force. The external force is generated by the electrical motor, driving the bowl shaft either by gear or using a belt drive. The centrifugal force developed by the motor exerts a force on all particles in the fuel. The heavy particles, like solids and water, are thrown to the periphery of the bowl, from where they are separated. The separation in the purifier happens based on the principle of difference in the specific gravity of various liquids and solids. If two different grades of liquid are mixed together in a tank and are left for some time, the denser fluid and solid particles will go down, and the lighter fluid will float on the surface. Suppose there is oil mixed with water and solid particles kept in a tank. As per the gravity separation, the solids will settle in the bottom. The water, being heavier than oil, will settle above the solids. The oil, which is the lighter liquid, will settle on the top. If we add angle baffle plates to the tank, the underside of each parallel plate provides more surface for suspended oil droplets to combine into larger globules and come up. The solid particle will also slide down the surface of each parallel plate. This allows the denser liquid and solids to settle at the bottom, while the lighter fluid will rise up to separation. Now let's understand the same concept when applied in a centrifugal separator. When the dirty oil enters the separator, it passes through plates and pushed upwards by the fluid flow. Fluid moving between the two plates has a velocity greatest at midpoint and minimum when approaching the plates. This is because the centrifugal force will retard the horizontal component of the movement for the heavier particles, causing them to approach the underside of the top disc, reducing its flow velocity. The lighter fluid rises due to the push of dirty liquid flow entering the separator. For heavier fluids and solids, the centrifugal force eventually overcomes the upward force acting on the particles due to fluid movement, and they start to move towards the outer rim and get collected near the sludge port. In this way, it can be seen that reducing the flow rate to a separator will tend to increase the quality of the output.